In this video, I am going to talk about how you can convert between polar and rectangular coordinates. So if we take a look here, remember that rectangular coordinates are an x comma y, which is a horizontal movement and a vertical movement to get to the point. And a polar coordinate consists of a radius, length, considered the pole, okay, and an angle. So this one, again, you'd have some angle of rotation and a radius. Okay, so this one's on this circle, so this one's out at a radius of 5, rotated to a 53.1 degree angle. So it's got some angle and a radius length. Remember that these 2 points are actually identical. So if I line up the XY axis with the polar point here, so let me just remove this grid, and you can see that the rectangular point and the polar point land in the exact same position. It's just a different way to really measure them, or to state where they are. So let's take a look at converting between the two. So first, let's look at rectangular to polar. So remember, again, horizontal, vertical movement for the rectangular point. So the polar point is just a different way of naming it. And you know how to do this back to geometry, okay? Because we just have to find this. That's going to be your radius length. And then we need to, And then we need to find this angle here, right? So it's really just solving a right triangle, because you know this measurement here, you know this one here. Okay, so we just need to figure out this angle and this radius or hypotenuse length, and we could name the polar point. So to find this radius length here, remember we could just do Pythagorean theorem. So r squared is equal to a squared, which is 3, plus b squared, which is 4, and then just solve. So we would have r squared equals 9 plus 16. Okay, so 9 and 16 is 25, square root, and you would get r equals 5. So remember, the polar point is r comma theta. So we have the r, which is 5. Now we just need this theta measurement here, okay? So in order to do this theta measurement, we just have a right triangle. So we're going to do right triangle trig. We're given the opposite 4 and the adjacent 3. So the tangent of theta is going to be equal to the opposite over the adjacent. And we would then just do that theta equals the tan inverse of 4/3. Okay, and you could use your calculator for this one, because it's not a nice value. We're going to get some that we're going to need to do from the unit circle. Okay, but for this example, we're just going to do degrees. So tan inverse of this would be 53.1 degrees. And then again, that's your theta measure. So you have that. So you have that r comma theta, which, if you remember, was the point that I just showed you. So that's going from rectangular to polar. And if we go from polar, given the polar coordinate, back to the rectangular, okay, again, very similar idea, but for rectangular, you're looking for the horizontal and vertical movement. Okay, so we're looking for, this vertical movement as the y coordinate and this horizontal movement as the x coordinate. Of course, we already know what they are going to be, right? And this r is 5. Remember that this theta is 53.1. We're getting that from this point here. And then we're looking for x and we're looking for y. So in order to find x, okay, we can set up a cosine function, because this is the adjacent, the 5 is the hypotenuse, and we're given this angle. So we would set up a cosine function. Okay, so cosine of the 53.1 is going to equal the adjacent side, which is x, over the hypotenuse, which is 5. Then we could just cross multiply here, right? Like multiply the 5 up. So we would have 5 times cosine of 53.1. Type that into our calculator, and that's going to give us our x coordinate. Okay, and so if you type that in, you're going to get your x coordinate is 3. Then we would do the same thing to find y. In this case, y is the opposite of the angle, and we have the hypotenuse, so we'd be setting up a sine function. Okay, so our sine function, so sine of the angle, 53.1, equals the opposite y over the hypotenuse, 5. Okay, again, you'll just multiply that 5 up. So we'll have 5 times sine of 53.1 is equal to y. And if you type that into your calculator, you are going to get y equals 4. Okay, and then remember that a rectangular point is x comma y. So x was 3, y was 4. Definitely what we remember from here. So then let's put this into generic terms here and give you a formula. Okay, so every time you're going to be given a rectangular point, you're going to be given an x and a y here, right? And you're going to be looking for, so let's, instead of having this say the actual number here, let's just put an x and a y here. Okay, so this is going to be x, this is going to be y. And again, you are looking for the r and the theta. Okay, so you're looking for this and you're looking for this. So remember, we found r by saying that r squared was equal to x squared plus y squared, the x coordinate squared plus the y coordinate squared. You would square those out and then you would square root both sides. Okay, so your r is going to be equal to the square root of whatever x squared plus y squared is. That's how you find r. Then your theta, remember, you know x and y, so you know the opposite and the adjacent. So remember that your theta was equal to the tan inverse, because we're solving for an angle, of y over x. Okay, so the tan inverse of the y coordinate divided by the x coordinate, and that is how you find the theta from rectangular points. Okay, then on polar points, so when you're given a polar coordinate, okay, again, let's not think about the, I'm just going to erase this, pretend that that's not there, okay, and you're given an r and you're given a theta, okay, so whatever they end up measuring, okay, you are going to be looking for this horizontal distance, x, and this vertical distance, y. That is what you're solving for. Okay, you know the blue part, you're solving for the red. So when we go to solve for x, remember x was, remember that we set up a cosine function. So you have cosine of theta was equal to x over r. Okay, remembering that you know the theta and the r, and then you multiplied the r up. So you got r times cosine of theta equals x. So here is your formula for finding x. So if I just write this way, so say x equals r times cosine of theta, that's your formula to find x. Similarly, you set up a sine function to find the y, because that's opposite over hypotenuse. Okay, so you did sine of theta equals y over r. Again, you know r, we'll multiply it up to the sine. So you'll end up with y equals r times sine of theta for your formula to find the y coordinate. All right, so let's use those. Okay, so we're going to be converting from polar to rectangular. Okay, so we know the r and we know the theta. We are looking for the x and the y. Okay, we're looking for the x and the y. So when we start looking at this, now that's just, I drew generic, okay? So let's take a look at these actual points and draw them in a decent position. And by decent position, I mean you know what quadrant this angle is in. Okay, so if I just draw these axes again, 5 pi over 4. Remember, this is 4 pi over 4, because that's 1 pi. So 5 pi over 4 is here in the third quadrant. Okay, and this radius is 2. The reason that I'm going to say that is because, because when you do these x, y coordinates, you now know it's in the third quadrant. So when you get an X and a Y, you better have a negative X value and a negative Y value for your ordered pair. Okay, if you don't, something went wrong. Okay, so remember, for the X coordinates, remember the formula was that X equals R times cosine of theta. Okay, and then Y equals R times sine of theta. That's it. So X equals the radius. Remember, this is your polar point, R theta. So the X is equal to 2 times cosine of 5 pi over 4. Okay, and 5 pi over 4, the cosine of 5 pi over 4 on your unit circle is negative root 2 over 2. So then multiply that, your 2's would cancel, and X is going to be equal to negative root 2. Sine, okay, so you'll, or for Y, so you're doing 2 times sine of 5 pi over 4. Okay, this the sine of 5 pi over 4, negative root 2 over 2 as well. 2's will cancel, so your Y is equal to negative root 2 as well. So your rectangular point, negative square root 2, negative square root 2. Next one, again converting polar to rectangular. So let's take a look at where this one is at on the grid just to make sure. So this is the radius, this is the length of the hypotenuse, 4 pi over 3. So here's 3 pi over 3. So 4 pi over 3 is this pi over 3 reference angle in the third quadrant. So again, as we're doing the X and the Y coordinate, it's going to be negative, negative. Okay, since this is a large angle here, the X value is going to be smaller than the Y value. So when you're looking at that. So again, X coordinate is R cosine theta. Remember, cosine and X always go together. So 6 square root 3 is the radius times cosine of 4 pi over 3. Okay, cosine of 4 pi over 3 is negative 1/2. Multiply those. So half of 6 is 3 with a negative. So this is negative 3 root 3. Find the Y value. R times sine of theta. So your R is 6 root 3. Sine of this angle, so the sine of 4 pi over 3 is negative root 3 over 2. Okay, so you got a couple things here. So maybe I'll just multiply this out with a 1 under here. So this will be negative 6 root 3 times 3. Root 3 times root 3 is root 9. 1 times 2 on the bottom is 2. So then you end up with, this is 3. Square root of 9 is 3. Times negative 6 is negative 18 on top divided by 2. So you get negative 9 for your Y coordinate. So negative 3 root 3 for the X, negative 9 for the Y. All right, let's do 2 that are converting rectangular to polar. Okay, so this is your X coordinate, this is your Y coordinate. Okay, you're looking for the R theta. Okay, so if I just kind of draw that triangle again to help you with the formula, remember this is your X and your Y. You are looking for R and you're looking for theta. Okay, this is going to be given to you. So remember, you're doing Pythagorean theorem to get the R. So the R value is from the formula, okay, is just X squared plus Y squared and the square root of that. And then remember that your theta, you have Y and X, which is opposite over adjacent. So that's a tan inverse of Y over X. So then we have R. So when we go to solve for R, we'll have, in this case, negative root 3 squared plus 1 squared. Okay, negative root 3 squared is positive root 3, and then plus 1. So you have root 4. So your R here is 2. Okay, and then let's look at where this actually is on the coordinate system here. So this is at negative root 3, 1. So it's in the second quadrant. Okay, so it's in the second quadrant, which is going to be helpful when we look at this angle to know what quadrant this is in. Okay, so let's do a tan inverse here to get theta. So tan inverse of 1 divided by negative root 3. So then you'll figure out on your unit circle, okay, what will give you a tangent of negative 1 over root 3. You may want to think about let's think about where we would get that. So remember on the unit circle that the coordinates are not a 1 and a root 3. Okay, so the top would have to have been 1/2 and the bottom would have been negative root 3 over 2. So you want to think of when is the y coordinate 1/2 and the x root 3 over 2 in this second quadrant. Okay, so your x is negative root 3 over 2, your y is 1/2. Okay, so negative root 3 over 2, 1/2. That's at the pi over 6 reference angle. Okay, so this would be the pi over 6 reference angle in your second quadrant. So remember, this is 6 pi over 6. Backwards, this will be 5 pi over 6. So theta is equal to 5 pi over 6. And you can look at your unit circle for these and look for where the tangent would be that with the ordered pair. So this one, again, r comma theta. And you won't be able to use your calculator in these because you need that exact radian measure in terms of pi. All right, then let's look at this one. 5 root 3 comma 0 is your xy. Okay, now if one of the coordinates is a 0, that means it's a quadrantal angle. Okay, which is going to be really make some of this a lot easier. So this will be, this point is at 5 square root 3, 0. Okay, this is your x and your y. So remember, we need the r value and the theta. Well, to go from the center to this, okay, it's just this straight line. So this angle, we haven't even moved. So the angle here is 0. And then the r is just the length of this. Well, that's going to be the same as the x value in this case. So your r is 5 root 3. So r comma theta, it's the same exact in polar as it is in rectangular. Now, if that had been the point, let's do one more. If that had been the point, the rectangular point, let's say 0, negative 5 root 3, just use the same thing. So 0, negative 5 root 3, okay, so that would be down here. So that would be, the point would be right here. So you would have this angle, okay, either that way or you could go the negative version. Depends on what the problem says. This last one said 0 is less than or equal to theta is less than 2 pi. So this one you needed to use the positive angle. So all the way around to here is 3 pi over 2 for your theta. And then the length of this, okay, again, it's down 5 root 3 in rectangular. Length is not going to be negative. So this r is not going to be negative. So the r is just going to be the length of that, not the negative for the direction. The direction in a polar point comes from the angle. So you're going to go all the way around here and then go 5 root 3. Okay, so for this one, it would be 5 root 3 comma 3 pi over 2.